1234.
85. Okay. 12 grams of each reactant mixed together. What mass of sodium nitrate can be produced? Alright. So we have to figure out which one of these is the limiting reactant. That's the first step. Once we find the limiting reactant, then we can find out the mass of sodium nitrate. We cannot find the mass of sodium nitrate until we first find the limiting reactant. That's the first thing we have to do, find the limiting reactant. Okay? So what we have to do to find the limiting reactant is start with 12 grams of either the lead nitrate or 12 grams of the sodium chromate and do a mass-to-mass calculation from one to the other. Okay? So if you want to start with lead nitrate, raise your hand now. One person. If you want to start with sodium chromate, raise your hand now. You voted twice for the same thing.
I think we should do the first one.
All right. Let's,
Do a coin toss.
you want to do a coin toss?
Yeah, if it says PB, just tails NA.
Huh?
Josh told me about that coin toss I did as you go to the office.
Alright, I got $5 on heads.
Okay, so heads we start with lead nitrate. You ready? Oh,
It's
that didn't work.
heads.
Let's get it so it falls on the paper. How about that?
What kind of coin is it?
A dime.
I bet tails.
There we go. Tails it is.
A bit tails.
So we're going to start with sodium chromate.
Kick or receive?
I'll kick it. Send it that way or that way?
Alright, so we're going to start with sodium chromate. Here's sodium chromate. Okay. So we need to start with 12 grams of that. Let's move that down here. 12.0 grams of sodium chromate. And put that over 1. We've got to get from grams of sodium chromate to the moles of sodium chromate. And for that we're going to need what? Molar mass. Sodium, chromium, oxygen. Sodium has an atomic mass of 22.989769. Chromium has an atomic mass of 51.9961. Oxygen has an atomic mass of 15.9994. And from the formula up here, let's see, I should have 2 sodiums. I didn't put that in there for some reason. I'm going to be careful about that. I've got 2 sodiums. I've got 1 chromium. And I've got 4 oxygens. Okay. So 22.989769 times 2, 45.979538. This is 51.9961. And then 15.9994 times 4, 63.9976. And notice how I've kept the columns of numbers lined up very neatly with them being arranged in a, making sure that the decimal places are decimal place column is also not lined up vertically. So what this shows us is there are a couple of empty slots over here. And that's what we're going to round off at the end. So let's add these numbers together. 63.9976 plus 51.9961 plus 45.979538. And I get 161.968138. 161.968138. .968138. So the last two digits get rounded off. We use an arrow to show that we're rounding off this answer. And write 161.968 grams of sodium chromate equals 1 mole of sodium chromate. As a quality statement then, is what we use to build the conversion unit we're going to need here. We've got to get to moles. So we want to match the units and species here with what we're going to put in the bottom of this fraction. And this side of the equality statement here, the left side, the first side, is what matches the units and species. So we put 161.968. Here's our matching units, grams, and the matching species, sodium chromate. And the other side of the equality statement, the other side of the equal sign, is 1 mole sodium chromate that goes in the top. And we can do this because this equality statement, when you arrange it in a fraction like that, gives you a fraction that equals 1. So this math is going to allow us to convert from one unit to another without changing the actual value. So grams are going to cancel just like x's and y's cancel in algebra. Sodium chromate cancels like x's and y's. And we're at moles. Okay, let's see. I can take this then and find the answer right here and then use that as a new starting amount. Or I can keep going with this problem and make one problem instead of 3.
No, do the
Huh?
do the new starting amount one.
Want to do the new starting amount one?
Yeah, because
Okay.
I have
0.074 0887. What?
Wait, okay. 0.074088709.
Okay. You didn't get that?
Your math wrong, Mr.
I
President.
might have done it.
What's wrong?
No, I didn't.
Yeah, your math.
Which math? This math down here with this math or that math?
Nah, when you started off, you got the wrong number. Do it manually. 8 comes down, 3 comes down, 5 plus 6 is 11, 1 more equals 12. So it'll be 6, 2, 3, 8. So you bring it over 1. Hold up, I got this. Hold up. So you bring up the 1. That's 10, it's 16, it's 22.
I added wrong?
Yes, it was 973. 973.
No, I just thought you were
238. Yeah, 973. 238. Yeah.
So these numbers are right, but this one's wrong?
Yes, you're starting them out.
Messed up on adding the 5.
Well, my spider senses was hitting, boy. I felt that one.
Yeah. You're right. 973238. Is that right?
Yes, sir. 97323.
Okay, so we need this math again. Well, I'm glad you guys caught that. That just shows you need to do your math twice. I'm just trying to get to this in a hurry and didn't help any much, I guess, when I make a mistake, huh? So that now becomes 86 here. 07408 is correct. Then 63303. And we're going to round off everything but the first 3 significant digits. So that becomes then 0.074. The 8 makes this round up to a 1 moles of Na2CrO4. Okay? And that becomes a new starting amount. 0.0741 moles Na2CrO4. Put it over 1. And the next thing we're going to need is a molar ratio. A molar ratio must come from a balanced chemical equation, and we don't have that yet. So we better start balancing the equation. These are our reactants, but we have to predict the products. Now, the way I've taught you to do this is you always predict the physical states, but this particular problem you can do it without having to predict physical states because it isn't asking you, well, what's the solid? It's only it tells you right away what I want is the mass of sodium nitrate. So if you could just predict the products without figuring out the physical states, that's fine. You don't have to go any further than that. So I'm going to do that without figuring out the physical states here. Okay? So lead is going to go with the chromate. This is a double replacement reaction. I have two ionic compounds, so the most likely type of reaction is going to be double replacement. So lead's going to go with the back of this. The front part goes with the back part. So we're going to put Pb and CrO4 together. Subscripts, remember, only travel when they're actually part of a polyatomic ion. And this 4 is part of this polyatomic ion. You can find that polyatomic ion on your list of common ions in your test references. Chromate is right there. Alright, we'll figure out whether it's balanced later. First I want to put everything together. So sodium then is going to go with the back part of this. And sodium has a subscript 2, but that's not part of a polyatomic ion, so that subscript does not travel. Nitrate is NO3. This 2 out here is not part of the polyatomic ion, but the 3 is. So the 3 travels, but the 2 doesn't. Now we want to balance the formulas. Lead can have more than one oxidation number. It can have a 2+ or a 4+ charge. Over here, this nitrate has a 1 negative charge. And if I have 2 of them, I need to have a 2+ lead. Does that make sense? Do I need to do the math for you? Okay. So if this is lead plus 2, or lead 2+ here, we're going to assume that that's what it is over here. So now let's look at chromate. I showed you where it was a moment ago. Chromate has a 2 negative charge. Well, if this is 2+ and that's 2 negative, we need 1 of each. Do I need to do the math for you there? Alright. Sodium has what kind of charge? What charge does sodium have? How about nitrate? What charge does it have? Anybody but Carolyn. I said anybody but Carolyn. One what?
Uno positive.
Not positive. Nitrate's a... Look it up. Don't just shout out an answer. 1+ and 1 negative. That's also balanced. So what do we do to what tool do we use for balancing equations?
AI.
Atom inventory, AI. So we're going to write out all our elements.
You better remember the answer.
How many leads on the left side?
It's 2 of them.
1 of them. 1 lead. How many nitrogens? How many oxygens? 6 here, but there's 4 over here too. Okay, how many sodiums?
2.
How many chromiums?
1.
Over here on the right hand side, how many leads are there? 1. How many nitrogens are there? 1 nitrogen. How many oxygens?
7.
3 and 7 makes 7. How many sodiums?
8.
How about chromiums?
1.
1. All right. What do we always say for last when we're balancing an equation?
Oxygen.
Okay, so where do you want to start? I'm going to start with nitrogen. PB's already balanced.
Go ahead, Mr. Nitrogen.
Okay, so I've got 2 over here on this side. I need 2 over here.
So put a 2 in front of the inner.
Put a 2 in front of these.
Yeah.
I can't put a 2 there
Because it's one.
because the formula's balanced. Once the formula's balanced, you got to leave it alone. Can't touch this.
Can't tamper with it.
All right, so the 2 in front here means that I'm multiplying everything in that formula. So that means I have how many sodiums? 2. Means I have 2 nitrogens. That's what I started out trying to fix. And how many oxygens do I have here? 2 times 3 is 6, plus that 4. 10. And it's balanced. So now I have a molar ratio I can derive from this equation. There's 1 sodium chromate. I need to match units and species with the previous step. 1 mole sodium chromate. And then I'm trying to get to, because I'm still trying to figure out the limiting reactant, I'm trying to get to the lead nitrate. 1, there's an implied 1 there as well.
This is a long.
Well, that's a 1 and 1. That's going to give me the same number, but it's going to change the species. Moles are going to cancel. Species here cancels. So the answer then, at this point, at this stage, is 0.0741 moles of lead nitrate. No, that's not 2 there, just NO3. Okay. That becomes a new starting amount. We have to find the molar mass again. We've got lead, we've got nitrogen and oxygen here. The atomic mass of lead is 207.2. Atomic mass of nitrogen is 14.0067. And oxygen is 15.9994. In the formula we have 1 lead, 2 nitrogens, 6 oxygens. Yep. So keeping all my everything lined up by decimal places here. I want 28 here, 0, 1, 3, 4 over here, and 15.9994 times 6. $95.9964. And I've got 3 empty slots over here. Remember, you can't put zeros there because that implies a degree of precision we don't have. Okay? So now we're going to add this number right here to these other 2. 28.0134 plus 207.2. Okay? Get 331.2098. But since I've got 3 empty slots in the last 3 columns, I need to round off the last 3 digits. So that becomes 331.2 grams of lead 2 nitrate equals 1 mole of lead 2 nitrate. Okay. Now then, that becomes, this equality statement allows us to build a conversion unit. The conversion unit equals 1. So we're going to change the amount without changing the value. And we're going to change the measurement unit without changing the value. So let's see, we want moles on the bottom here because they match moles on the top here. 1 mole of lead nitrate then goes here. And then the other side of the equality statement goes on the top, 331.2 grams of lead nitrate. All right. Now, moles cancel like X's and Y's in algebra, and so too does lead 2 nitrate. We're ready to do the math here. Okay, let's see. I've got 0.0741 times 331.2, and I get 24.54192. I need to round it off to how many digits? 3 digits. This number has 3 significant digits. Leading zeros are not significant. So we want to count 1, 2, 3 and underline, draw an arrow. And we get 24.5 grams of lead 2 nitrate. Okay? Now, here's how we figure out what the limiting reactant is. This number is not truly real. It's a theoretical number. It essentially is, this is the amount of lead nitrate I need to completely react with the 12 grams of sodium chromate I started with. What I actually have is a lot more than, what I need then is a lot more than I actually have. The problem says I only have 12 grams of it. So the rule I've given you is, if the amount you calculate is greater than the amount you're given, that species is the limiting reactant. Okay, so if the amount you calculate is greater than the amount you're given, that species is the limiting reactant. Therefore, that triangle dotted thing there means therefore, lead 2 nitrate is the limiting reactant in this problem. Okay, now the problem isn't asking for the limiting reactant, however. It's asking for what mass of sodium nitrate it would produce. But this is what we have to start with. Yes, Carolyn?
So you said that if it's greater than it's the one thing?
If the amount you calculate, this is the amount we calculated, is greater than the amount we were given 12, then this species, the chemical species here, that species is the limiting reactant. Okay? Now, I'm careful about saying species because when we start our new set of calculations, we're not going to start with this amount. This is a theoretical amount. It's not real. We're going to start with the given amount, but of that species. Okay? So let's do that. Let's go back over here and get a new sheet of paper out. Yes? Huh? Yeah. So now we're going to start with 12.0 grams. Yes? What? Yes? So we're going to start with that species. We're going to start with the 12 grams we were actually given. You start with the given amount of the limiting reactant. The given amount was 12 grams. Okay, we're going to put that over 1 because that's our starting amount. And we've got to convert from grams to moles. But we've already done a molar mass calculation here. We don't have to do it again if we've got it already. We're just going to use that to build our conversion unit now. So we can put 331.2 grams of lead 2 nitrate on the bottom here. And we're going to do that because it matches the units and species of our starting amount. For the other side of the equality statement, 1 mole of lead 2 nitrate on the top. Okay, that allows us to cancel units and species again. So now it's 12 divided by 331.2.
0.036231884.
What'd you get?
0.03623.
Okay. 0.036231881. That it? Okay. How many significant digits do I need?
4. No,
3. But the first 2 digits are not significant. Those first 2 are insignificant digits.
Second 3.
1, 2, 3. We're going to underline from there over. Draw an arrow. We get 0.0362 moles of lead nitrate. Oops, I don't want that. I want this here and then in parentheses. Okay, now that's our first stage of a 3-stage problem. So we're going to have to make that a new starting amount, 0.0362 moles of lead-2 nitrate. Put it over 1, and now we need a molar ratio to get from one species to another. In this case, we're starting with lead-2 nitrate, but we're trying to get to the sodium nitrate. The problem asks for the mass of sodium nitrate. So in this problem, we got 1 mole of this, 2 moles of that. Okay? So 1 mole from the equation but we've got 2 moles of sodium nitrate.
Wake up.
I'm going to cancel. And we're going to multiply. Because you might have something that's long on the test. Because that's what chemistry is about. Because the state standards in South Carolina say you're supposed to know this stuff.
I am.
Okay? Alright, that's moles. Please be quiet and give me your attention.
That's true.
Alright, so 0.0724 moles NaNO3 is our last starting amount here for this problem. But we've got to get from moles to mass. And we do not yet have a molar mass calculated for sodium nitrate. So let's calculate the molar mass for sodium nitrate. I'll do it on this sheet of paper, actually. So we've got sodium, nitrogen, oxygen. Sodium's atomic mass is 22.98989,769. Nitrogen is 14.0067, and oxygen is 15.9994. There's 1 sodium, 1 nitrogen, times 3 oxygens.
You get 84.994669.
And 47.9982. And we've got a couple empty slots over here. Well, the 6 and the 9. You said 84.994669?
Yes, sir.
Good. The last 2 digits came from empty slots.
So you're going to round it off.
Round it off.
To 84.99466.
Yep. 447. This 6, okay. Yep.
Yeah, I was right.
That's grams of sodium nitrate
Wait, no, I was wrong.
equals 1 mole of sodium nitrate. Okay? Alright, there's an equality statement for this conversion unit. 1 mole goes in the bottom because it matches the moles and units and species here.
Mass of the top.
Mass goes on the top. 84.9947 grams of sodium nitrate. I'll cancel first and then do the math. Okay? So, 0.0724 times 84.9947 Okay, we're going to round it off to how many digits? 3. Leading zeros are not significant. 1, 2, 3 digits. 1, 2, 3 digits here.
Bring it down
6.15 grams of sodium nitrate. And that's what the question asks you for, the mass of the sodium nitrate that might be formed.